Hello, and welcome to Algebra Unit 4-2 Lesson 1. Today's objective is that scholars will recognize and apply square root functions to real-world situations. So the first question is, what is a square root function? So a square root function looks like this. We have f of x equals the square root of x. In order to figure out exactly what that looks like, make a table of values for it. So we see if x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. Please remember that even though we know that 4 actually has two square roots, it has the square root of 4 is both positive and negative 2. When we're writing it like this, we only are looking at the positive roots. You'll notice I only list the positive roots. And then we can use that to graph it. So you can see on this graph that we have a nice minimum here of 0. So both our domain and our range. Our domain is 0 is less than or equal to x, which is less than infinity. And the same thing with our range. Our range, 0 is less than or equal to y, which is less than or equal to infinity. So you can see we do not go down below this 0 for either of them. So let's talk about how we look at the rate of change. So for this function, this is f of x equals the square root of x. How does the average rate of change from 0 to 0.3 compare to the average rate of change from 0.3 to 0.6. So in this case, we're looking at two separate sections. The first section we're looking at is from 0 to 0.3. The second set that we are looking at is from 0.3 to 0.6. And if we look at those sections on the graph, I'm going to sort of do this on the graph. So you can see that section, and you can see this section. We could find our average rate of change by simply taking the points. So for x equals, for 0 to 3, we have the points 0 and 3, or 0.3. So 0, 0, so the point 0, 0, and the point 0.3, and then let's see, that looks like about 0.55. So, and then at 0.6, I'm looking at the point 0.6 and 0.77. These are estimates. Now I can put these into my slope formula like I've shown you several times. Put these into our slope formula and go, okay, so I have 0 minus 0.55 over 0 minus 0.3 to find the rate between 0 and 3. And that would give me, I end up with positive 0.55 over 0.3, so that's a little less than 2. And then for the rate from 0.3 to 0.6, I would have 0.55 minus 0.77 over 0.3 minus 0.6. So in this case, I would have something like 0.22 over 0.3. In this case, they didn't ask us for exact. They just asked us to compare. How does the average rate of change compare? So obviously, the rate of change here, this section of my graph, is greater than the rate of change here. You can see how much greater that change is. So you just need to know that when we're looking at these square root functions, they will start off with a greater rate of change and it will continue to decrease. The rate of change will continue to decrease as it goes on. Well, now let's talk about transforming a square root function. So we know that this blue line right here represents f of x equals the square root of x. And then this red line here is f of x equals the square root of x plus 3. If the plus 3 is outside the square root symbol, please note that it is outside my radical, then it just makes it my function move up and down. Plus 3 moves up 3. So we go up 3. If it was minus 3, we would move down 3. Nice and simple. Well, what about when it's inside? Notice this is inside. When it's inside, a plus 3 will move it left 3. Left 3 is plus 3. Okay, so plus 3 inside will move it left 3. If it is a minus 3, it would move it right 3. So quick review when we're talking about transforming. When we are within the square root symbol, it moves it left, right. If we are outside the square root symbol, it moves it up, down. So square root of x plus 2 goes up 2. Square root of x plus 2 is left 2. So please make sure you don't get those confused. Good luck on your practice, and I will see you all in class. Bye-bye.